chapter 8.5 deals with scientific notation. And scientific notation was invented because of very large numbers. Let's think of the size of the universe, 7.8 billion light years across. If I have to write 7.8 billion, I'm going to have to write this. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. That is a huge number, okay? 7.8, that's a huge, huge number. That is the size of the universe. So, because of our limited space in textbooks, etc., scientists develop what we call scientific notation, and this is how it works. If I have a very small number, like this one, 0.00325, my decimal point at the moment is right here. What I need to do is I need to move the decimal point 3 places to the right. I say 1, 2, 3 places to the right. Okay? So that I can say this is 3.25 times 10 to the minus 3. When it's a small number, remember this, when it's a small number and when I move the decimal point to the right, it's 10 to the minus 3. If it's a very small number, 0.000 something, it must always be to the negative here. Your answer should be like that. The other thing that you need to remember about scientific notation is that there is always only one number before the decimal point. There can never be 2 or 3 or 4. Then it's not scientific notation, and it's not correct scientific notation. Okay, so it's 3.25 times 10 to the minus 3. Now here, this one says 2 thousandths. That means it's 2, that tells me it's a small number. So it means there's 3, a thousandth means there's 1, 2, 3 places after the decimal point. So I'm going to have 0.002. That is what 2,000ths look like. And then if I rewrite that in scientific notation, I'm going to move the decimal point 1, 2, 3 places. So this becomes 2.0 times 10 to the 1, 2, 3, and it's to the right, so it's negative 3. Okay? Now we have a very large number, 41.8 billion. Okay, now 41.8 billion means that there's going to be 9 zeros or 9 decimal places after the point, 9 digits after the point. So here's the point, and it's a billion, so there's 3, 6, 9 places. Okay, now I want to rewrite this in scientific notation, so I start here at the end, and now I'm going to count to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this becomes 4.18 times 10. Now because I counted it to the left, I went this direction, and it is also a very large number. This is going to be positive. Okay, so here, how many did I count? Some 9. Okay, to the 9. 4.18 times 10 to the 9.
10
okay?
to the 10.
Did I say to the 10?
Yeah.
Oh, sorry. I counted that one in as well, to the 10. Thank you, thank you, thank you. We counted to the 10. So it's 10 to the 10. Okay? So number of places that you count here. And although the decimal point was there, it's moving this way. So it's 4.18 times 10 to the 10. Now here, I need to rewrite this into ordinary notation. Now that 9 tells me it's a very large number because it's a positive 9. And that there are 9 decimal places after this decimal point. 9 places after the decimal point. So I'm going to say this is... So I need to basically move this decimal point 9 places to the right. Okay, so it's 704. Okay, rewrite it as 704. And then I'm saying I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now let's fill in zeros. 1, 2, 3, 4, 5, 6, 7 zeros. Let's just count back. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is where the decimal point was. Okay, so that is the number if I write it out in ordinary notation. This one here is to the negative, which means I'm going to have to go back the other direction, because now I'm doing the opposite from writing in scientific notation. So this is 4.69, okay, and I'm going to go back 6 places. So let's go back 6 places from the decimal point. That's where we start. 1, 2, 3, 4, 5, 6. So fill in the zeros. 1, 2, 3, 4, 5 zeros. And this decimal point that was there moves all the way back here, becomes 0.0000469. Okay? And that is the answer for that. So that should get you going on this section. You can study the rest on your own.